All right, so let's get started on chapter 13. We are talking about algebraic expressions. So this is kind of going back to when we talked about like terms. We had like terms, we combined those like terms, we found similar terms. So we're doing very similar work, but just at a different level. So if I start here, and if you're following along with the notes, which you should be, you can go ahead and we're talking about like terms. And again, bear with me as my handwriting might not be the best on here. So like terms, remember, these are terms that have the same what? The same variables. Remember, variables are just letters that represent unknowns. So like terms are variables, are terms that have the same variables raised to the same, try to think if you can remember, the same exponents. Exponents. Meaning, remember, like terms, x, that's a different term than x squared. So x and x squared are two different terms because they both have different exponents. So that's all that means. And then blank terms are also their own like terms. Remember, this is constants. So remember, constants meaning they don't have a variable. Any number without a variable is a constant. Constants, aka like 5, or if I had 12.5, that's a constant because it's a value that's not changing. These are both like terms. I can combine 12.5 and 5. So for example 1, if I wanted to identify the terms and like terms in both of these expressions, well, remember when I had you guys first look for and you circled and put different shapes around your different terms? Well, here I'm noticing I can use different colors if I wanted 9x. Okay, well that's a positive 9x. And do I see any more like terms, meaning any more terms with the variable of x? -2 plus 7. Oh, here we go. This is a minus x. Now be very, 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 very careful. There is a huge difference between just circling an x and circling this minus x, also known as a negative x. So now I know if I were to combine my like terms and simplify, I have a 9x, take away an x. So then I look at what are the other variables I have. Well, here's a -2, or same thing as a -2, and then I have a positive, a plus 7. So I can rewrite this in any order as long as I keep that sign in front. So I'll put this as a plus 7 minus 2. So now I can simplify. If I have 9 x's and I take away 1 x, how many x's do I have? Well, I have 8 x's. And if I have 7 whole and I take away 2 whole, how many wholes do I have now? 5. So that's a positive 5 that I have. So basically I just simplified this expression and I can rewrite this as 8x plus 5. This other one, if I have, so I identified the terms and the like terms, and it actually didn't even ask you to simplify it, but we just did that instead. For this one, let's do a very similar thing. I'm noticing my first term here is a z squared. Are there any more z's that are being squared? Here's a 5z, but remember, z squared is not the same term as a z, technically right now, to the first power. A z is also equal to z to the first power. So I have a -3z squared, so I can circle that as a part, and I don't see any other z squares. So if I were to simplify my like terms, this is a z squared minus 3z squared. So you can kind of think about this as like its own little problem right now. We kind of solve and simplify what we can and what we know. So what are the other terms we have here? I have a 5z. This is a positive 5z. Do I have any more variables of just z? Yes, there's this positive 1z, or z. Remember, a 1 times z, a 1 having 1 of z is equal to just a z. So on this side I can say, okay, this is now plus, because these are both positive, plus a 5z plus another z. So let's go ahead and simplify. If I have 1z squared, but then I take away 3z squared, well, I know that my variable, I'm talking about z squared, and you can think about this as, well, then there's an invisible 1 right here. 1z squared is the same as z squared, so 1 minus 3 is a -2. So z squared minus 3z squared, this is really a negative 2z squared. And then I want to simplify this. If I have 5z's and I add on a z, well, that's plus, that's a positive. I now have 6z's. So if I were to simplify b, I identified the red are my like terms, the blue are my like terms, and then we went one step further and we actually simplified it together. We actually simplified that together. So let's move down to our new problems. Let me just upload really quickly our other. Okay, so now we are here. Oops. So I want to write here an algebraic expression, and so bear with me as I try to write this in here. So this is an algebraic, if you can read this, I'm not good at this. An algebraic expression, so any expression, so not an equal sign, any expression that has variables in it is an algebraic expression, and we know that it's in simplest form when it has no like terms. It has no more like terms left that can be combined. Has no like terms, and it has no parentheses. And remember, to combine like terms that have all variables, we are going to use the distributive property, which will kind of make sense in a little bit. Okay, this is supposed to say distributive property. And we use the distributive property to add or subtract the coefficients. So to add or subtract the coefficients. So for example, in here in example 2, simplifying an algebraic expression, all this really means is first we start off with what are our like terms? Can I combine any like terms? Well, right off the bat I see I have a 3/4 y. Do I have any more y variables? Yes, there's a negative 1/2 y. Or I can think about that as a minus 1/2 y. So if I were to simplify this, I could say, well, 3/4 y, I can subtract a 1/2y, 1/2 y. Because remember, you can't subtract apples from oranges, but you can subtract apples from apples. So make sure your variables are the same. Now, what other variables do I have? Well, I have two constants. I have a positive 12, so that's a plus 12. Remember, these are all part of the same algebraic expression. And then I have a minus 6. So let's go ahead and solve. And again, we have to solve separately. I can't do 3/4 y plus 12 because I can't simplify that. That would just be 12 plus 3/4 y. There's really nothing more I can do. I can only add and subtract like terms. So here, I'm going to have to make common denominators. So 3/4 y, well, 1/2 I know I can change into, that's really 2/4. 1/2 is the same as 2/4. So 3/4 minus 2/4, 3 minus 1 is 1. I keep my fourth, so I'm left with 1/4 y. And then here, a positive 12, take away 6 is a positive 6, so I have plus 6. So here's how I can simplify that expression. My answer would be 1/4 y plus 6. Now, get used to having this be your answer. There is no one number that's your answer because you're not solving anything. You don't know what y is. You can't solve anything. Your answer, you'll have to get comfortable with leaving your answer with a variable like this. So this is where kind of the distributive property comes into play. This is where the distributive property comes into play. This is sort of what we're talking about here. You can add or subtract the same coefficients. This is what gives this meaning. So if I want to simplify this, the first thing I notice, I have a variable n inside my parentheses, meaning I am going to have to use distributive property and distribute. This is a negative 1/2 that's being distributed to all of the terms inside my parentheses. So what's really going on here right now is I have a negative 1/2. I distribute it I use the distributive property. This is a negative 1/2 times a 6n, and I can be consistent with my fractions and write this as 6n over 1. And this is being, so this I'm going to have to solve this separately. A negative 1/2 times 6n plus I have a negative 1/2. Remember, when it hits this parentheses, bam, it's being multiplied. A negative 1/2 times 4 times, and I can write that as 4/1. So I want to solve both of these separate, and then I add in, I still have this plus 2n. So that was the first step. So now let's simplify, bring down what we know. A negative times a positive will be a negative, and let's use a different color here. So a negative times a positive is a negative. 1 times 6n is just 6n over 2 times 1 is 2 plus, again, a negative times a positive is a negative. 1 times 4 is 4. 2 times 1 is 2. I don't have any variables, and then I'm left with plus 2n. So I'm getting further. Now, I notice I can simplify this even further. A negative 6n over 2, well, 6 divided by 2 is 3. So I can cross out 6 divided by 2. This is really just a negative 3n. So I have a negative 3n plus, what can I simplify negative 4 over 2 to? 4 divided by 2 is 2. So this is a negative 2. Now I can turn this whole thing, instead of saying plus a negative 2, really what I can write is that this is a plus negative 2 is the same thing, remember, as just a minus 2. So this is now minus 2. So plus a negative 4 over 2 is the same thing as minus 2. And then I have plus my 2n. So now are there any similar terms I can combine? Yes, I have a negative or a minus 3n and a positive 2n. So I can rewrite this as, well, what is 2n minus 3n? That's going to equal a negative 1n, or just a negative n, and then I'm left here with this minus 2. And I can't do any more simplification, so it's a negative n minus 2. So if I were to simplify this entire thing would end up being a negative n minus 2, and that is going to be my answer.